Let's go through liquid 1027. Long is the arithmetic subsequences. So this question gives us an array nums and the integer array nums. Return the length of longest arithmetic subsequence. The length in nums. So let's look at the example one. You see 3, 6, 9, 12. The longest arithmetic subsequence is 4. The length is 4. Let's see, because the common diff is 3. 3 plus 3 equals 6. 6 plus 3 equals 9. 9 plus 6, 3 equals 12. And the second one, the longest arithmetic subsequence is 4, 7, 10. So every element has been increased by, in the subsequence increased by 3. And the third one, the longest arithmetic subsequence is 20, 15, 10, 5. So let's see the comma arithmetic diff. Let's see that is minus 5. Let's look at the range. You'll see the range of the nums is 1000, and the number has small equal to 500. So this gives us some kind of hint that we should iterate those kind of nums and also have the nums range as some kind of another dimension for this question. We can do use some kind of tool array. For example, let's call GP, right? What's new int, for example, A, right? So we know the DPI will be the longest subsequences, arithmetic subsequences up to this I. But for this question, it seems that we should have another factor should be included. So what we're thinking about that is that we can put the common diff into another dimension, right? So the common diff, how can we, what is the range? So we'll see the common diff, the worst case, right? That is because the number is from 0 to 500. The worst case, I mean, if it is smaller, it's going to decrease. So the smallest common diff is minus 500. And the biggest common difference sequence is 500, right? So there is negative and a positive number. So what we think about is that we can shift this number to plus 500, right? So we see the common diff will be from 0 to 1000, right? We shift plus 500, right? Do our shifting because this one does not have a negative for integer array. So we just set this one as 1001, right? So so we'll say the dpij will mean up to at the longest arithmetic subsequence n with index I, right? And with comma diff j, right? So we'll say for this j, we shift 500. So let's look at how can do the transformation, right? So we know for every dpij, what we do is that we need to go through for index I, we should go through from 0 to to I minus 1, right? Trying to see if if there is some kind of dpkj, right? In here, if there is some kind of dpkj here, um, we trying to see whether then this kind of number um, can if we find this kind of k index, right, then this kind of number can add 1, right, to with our current nums I. So our nums ij should be the in the previous index I to from 0 to I minus 1, the maximum dp kj plus 1, right? And we iterate this kind of I and find in every dpij, find the biggest one. So that will be our case, right? So let's just record for this. So we know int a equals nums dot length, right? So we know for every d in dp, right? So the initial length, the subsequence that is the number itself can be a subsequence. So we can have arrays 0 d as 1, right? And it says that this number length should greater or equal to 2, right? So we know if this array has 2 numbers, the minimal result should be 2. Right? So then what we do is that we iterate this kind of for int I equals 1, I smaller than I plus plus, right? So then we have for int j equals 0, j is smaller than I, j plus plus. And then we'll say, let's get the common diff. So we'll say d equals nums I minus nums j, right? We say this common diff, it may have, if we write this, the data range is minus 500 to 500, right? So we can shift this one to be positive number, right? So we'll say dp I d, right? A moment ago, we say j is a diff, right? So let's put this one into positive k, right? So and also put j here. Let's say there is d here because d is like a diff, right? We know dp I d, right, means up to I, comma diff d, the max length of arithmetic subsequence. So dpid equals max dot max dp k d plus 1 and dpid, right? And we know if we need to have the result, right? So for every dpid, we need to compare with its result. So we can have result equal math.max result up by d. Right? In the end, we just return result. The time complexity, let's see, this is a 2 for loop. So this is O(n) square. And this kind of D, right? We just have 2 for loop, right? So we calculate n square times. And for the space, it is n multiplied by 1001, right? Let's write Python code for this as well. So we'll say n equals length nums, and we're going to have dp equals let's say because every number it will be the subsequences will be at least 1, right? So for every this kind of dp is a 2-dimensional dp, right? So that means and at this index I, the for the diff, what's a diff d, what's the maximal subsequences length up to I, right? So I see we can initial the value as 1 because every number itself, right? No matter what is the common diff it will be a subsequence. The set as 1, 0, 1, right? But for this one, if we don't set a 1, 0, 1, let me see. Yeah. Yeah, we set that this as a 101 because the minus 500 to 500 the range, right? But the thing is that for Python, because it allow the negative number, so if we do not shift the comma diff, it's still fine, right? So let's say for mean range, and so what we do is that for I in range 1 to n, and for j in range I. So I say d equals nums I. Let's set this one as k, right? Because we I k minus nums k, right? If we don't plus 500, it is fine, right? Because we just need to have this array be able to put the values. And we'll have dpi d equals max dpi d and dp k d plus 1, right? So for every result, you have a result initial value set as 2, right? Result equals max result dpi d. In the end, we just return result.